Okay, exercise 6F, projectile motion. Now, in this exercise, there's nothing new, all right? There is no new content at all. For the extension to a projectile motion, I reckon it just, the question is just getting a bit harder. You probably have like two particles that project at the same time or at different time or towards each other. So yeah, and then you might just get a more question that's actually a proof question rather than just a solve question. All right, so in this lesson, I'm just going to show you like two example questions from the exercise, and you can try the exercise questions and see if you have any issues. Obviously, let me know if you do. So let's have a look at question 6 from exercise 6F first. Jeffrey hit a golf ball that was lying on the ground and level ground 2 seconds into flight. Okay, so I'm just going to highlight important information that when I read through the questions, right? 2 seconds into the flight, the ball has just cleared a 28-meter tall tree, okay, which is 24 square root of 5 meter from where the ball was hit. Okay, so that's important, all right, interesting. Let V, capital V, be the initial speed. Let angle theta be the angle above the horizontal at which the ball is hit. Take the G is equal to 10. Okay, so I've got all the information I need. Okay, all I need to do right now is just draw a simple diagram. Okay, so I've got a ball that's hit. Okay, towards that direction here, as you can see, and then it says, what am I doing here? It says it just cleared a wall, okay? A tree, sorry, 28-meter tree. Okay, that's 24 square root of 5 meters away from the ball was hit. Okay, so in that case here, what you can do is at this point, so basically at this point you can say, hey, at this point, maybe I could just remove this line here. At this point, the height is 28 meters. Okay, that's a 28-meter tall tree, and the distance horizontally is 24 square root of 5. All right, so the ball is hit here. Initially, the velocity is v meter per second with an initial angle of theta. All right, so with this information, we should be able to just do the questions now. All right, so I don't need to read the question anymore. I've got all the information I needed. All right, so let's just look at question A. Show that the horizontal vertical components of the displacement of the ball from the initial position are just equal to these two expressions here. So these are very standard, like solving show question. We start with an x double dot. All right, horizontal acceleration is equal to 0. Horizontal velocity is equal to, if you integrate 0, it's just equal to c, which is the horizontal initial velocity, which is v cosine theta. And then horizontal displacement, if you integrate again, it's vt cosine theta. All right, next, y double dot is minus g. That's the vertical acceleration, the only acceleration this has. So y dash is equal to v gt plus u sine theta. And then lastly, y is equal to half gt square plus, in this case, it's not u, it's v, vt sine theta here. Since we know g is equal to 10, so therefore if we do the substitution there, all right, we've got x is equal to vt cot theta, and then y is equal to half times by g, which is negative 5, t squared plus vt sine theta. All right, so this is our two initial component of the motion equation here. All right, so once we have that, now we should be able to start to show v cosine theta is equal to that, and v sine theta is equal to 24. So how would you show this? All right, we've got these two, but we're missing x, and y. Okay, we know t equals to 2, okay? So there is no t here in the expression, as you can see. So that's pretty easy. At this point, time is equal to 2 seconds, okay? So now what we have to do is substitute everything we have, all right? We're going to have sub x equal to 2, y equals to 28, x equal to 24 square root of 5, all right, into the xt equation and yt equations, all right? So once you actually substitute into these two, then you're going to end up with 2 is equal to v times by 2 cosine theta. Okay. Oh, that's not 2. X is not equal to 2. X is equal to 24 square root of 5. Okay, so that becomes 12 square root of 5 is equal to v cos theta here. What does the question ask us to prove? And that's all. question asks us to prove v cosine theta is equal to 12 square root of 5. We've got it here. All right, the next one is we just need to substitute into the y. So the y is equal to 28 is equal to minus 5 times by 2 squared. T is equal to 2 plus v times by 2 sine theta. That's 28 minus 10 times by 2v sine theta. So it becomes 38 2v sine theta. So I guess 19 is equal to v sine theta. Okay, so if my calculation is right, nope. According to the question, v sine theta is equal to 24. Where did I make a mistake here? Okay. Yeah, of course, I made an algebra mistake. 2 squared is equal to 4. 4 times by 5 is 20. Not 10, but 20. So if that's equal to 20, obviously that becomes 48. 48. Okay, oops, that's terrible, 48. And that becomes 24. All right, now that's the correct answer here. All right, so 24v is equal to v sine theta. Okay, now question C. By squaring and adding find v, find theta to the nearest minute. Okay, so it even tells you what to do. So it's a pretty simple and straightforward, question day. Okay, so question C, what we need to do is we've got two equations here, and we have two unknown, v and theta. So what we need to do is find out what's v, find out what is theta using a simultaneous equation method. All right, so all we have to do is we square the one, that's v squared, cos square theta is, we square 12 square root of 5. Let's have a look what that equals to. That's 720. And if we square the equation 2, that's v squared sine square theta is 24 square. That's 476. Okay. Once we finish that, we can actually add in 1 square plus 2 square together to use the trig property. Okay. One of the identity, cos square theta plus sine square theta is equal to 1. So we end up with this. Okay. So therefore, we end up with v squared is equal to 720 plus 476. That's 1,296. So therefore, velocity, or the initial velocity, is equal to 36 meters per second. All right, it's a pretty nice number here. It's all designed, of course. All right, so once we've got the velocity is equal to 36 meters per second, what does the question ask us to do? Okay, find theta to the nearest minute. Okay, all right. So now what we need to do is substitute this number back into the expression, into other, first equation or the second equation to find out what theta equals to. So if we sub v equal to 36 into equation 2, we end up with sine theta is 24 over 36. Theta is equal to, now we need to make sure the answer is to the nearest minute. So let's see. That's 41 degrees and 49 minutes. Okay, so that's the answer. So it's actually a really simple question, to be honest. It's not really an extension 2 level at all. It's just like an extension 1 and normal extension 1 projectile motion question. All right, question D. Find to the nearest meter how far Jeffrey hit the ball. So we need to find the range. Okay. So in order for us to find the range, we need to let y equals to 0 to find the time, how long it takes for the particle to reach the ground. Okay, so we do have the y equation, which is this equation here, and let's just copy this equation to the point here. All right. Okay, so we're just letting y equal to 0. So therefore we get negative 5t squared plus v. Now, do we know what's v? Yes, we do. We know what's v sine theta. We know what's v sine theta. Okay, v sine theta is equal to 24. Okay, so in that case, we can just replace the v sine theta equals to 24t is equal to 0. Okay, so that way it's just much easier, so you don't have to substitute theta and the velocity back into here. All right, so we take the t outside. That's negative 5t minus 24 is equal to 0. T equal to 0. T is equal to that's plus, yes, 24 over 5. Okay, so 24 over 5, that's 4.8 seconds later. All right, so then all I have to do now is substitute t equals to 4.8 seconds into the x component, all right, the xt component, which is vt cosine theta. So x is equal to vt cos theta. Now, again, we know what v cosine theta equals to. V cosine theta is equal to 12 square root of 5. Okay, so all we have to do is use 12 square root of 5 multiplied by the time. Okay, and we should be able to just end up with a number here. So what does the question ask us to do? To nearest meter. So that's 128.79 meters, okay? And then that becomes to nearest meter, that becomes 129 meters. Okay, that's to the nearest meter. All right, and that's all for this question. It's a really simple question, as you can see. I can just simply put this question into an extension 1, and I'm pretty sure extension 1 student can solve it without any really much of difficulties of this question here. All right, let's have a look at the next one. Let's just hope this question is slightly harder. But to be honest, the entire exercise are pretty straightforward. I'm pretty sure you guys can do it. All right, question 9. Sophia throw a ball with a velocity. Let's just highlight the important information. Velocity, okay, that's the initial velocity. From a point that's exactly 1 meter above the ground, okay, that's important. Where she was standing on, the ball traveled towards a wall of a tall building that's 16 meters away, okay. The plane in which the ball traveled was perpendicular to the wall, all right. The ball struck the wall 16 meters above the ground. Yep, take the G is equal to 10. Okay, so I've got all the information drawn on the pictures as well, okay. So that's sort of enough. I just need to add a few things. So if you think about this, that's the angle here, and the initial velocity is equal to 20 meters per second. And that's about it, right? And that's 1, okay? And that's 16. Yep, all right. So let's start with the question. Let the origin be the point on the ground. So this is the origin, okay? Show that t second later, x is equal to that function and y is equal to the function here, where the angle is the angle above the horizontal where the ball is originally from. So the first question again is just to prove, all right? Prove the equation of the motion. That's easy. We'll start with x double dot is equal to 0. X dot is equal to v cos theta, and x is equal to vt cos theta. Okay, now we know initial velocity is 20. Okay, so therefore when we substitute inside, we get x is equal to 20t cosine theta. Okay, that's all for the first one. For the second one, y double dash is minus g. Y dot is minus gt plus v sine theta. And then y is equal to minus half gt squared plus vt sine theta, and this time plus c. All right, we do have the horizontal, like a vertical difference here. Okay, the starting point is different. So now we're going to substitute numbers inside. G is equal to 10, v is equal to 20. This time we know the c is when t equal to 0, c is equal to 1 meter above the ground. Okay, so therefore if we substitute everything inside, y is equal to minus 5t squared plus 20t sine theta plus 1. Okay, pretty sure that's the answer here once we actually substitute. Okay, so that's part A finished. Now part B, the ball hit the wall after t second, the capital T seconds. Show that these two expressions here. Okay, hit the wall after t seconds. Now if you think about this, hit the wall at this point, okay, we can find the coordinate at this point. At this point, the x-coordinate is actually equals to 16. And the y-coordinate is also equal to 16 according to this point as the origin. Okay, so all I have to do now is substitute the numbers in. All right, so we sub t equals to capital T, x equal to 16, now y equal to 16 into both equation there. So that gives us 16, 20t cosine theta. All right, and what do we do? Yeah, that's all. We divide by 4 both sides. We'll get 4 equals to 5t cos theta, and that's it. Next, we substitute the y, 16 equals to minus 5 capital T squared plus 20 capital T sine theta plus 1. Do we need to simplify? Yes. What do we do here? We move the 1 over. That gives us 15 minus 5t squared plus 20t sine theta. So if we divide everything by 5, we end up with 3. 4t sine theta minus t squared, and that is the answer. Okay. All right, next we need to show that, okay, so now it's the equation of the trajectory. If you look at this, we need to show the equation in terms of tangent, okay? It's pretty easy, all right? Like, if you think about it, the question is actually scaffolded, right? So for part C, all you need to do is to combine the two equations we have now, like these two, together to get like a tangent equation. I hope that's the right way of doing it. And it looks like there is no t here inside, so we just need to find the t, substitute into here, and we've got the answer we need. All right, so we'll start with this equation here. Capital T is 4/5 cosine theta. And if we substitute this one back in, all right, so we sub capital T into this, we end up with 3 equals to 4 times by, sorry, is that 4? Yeah. 4 times by 4/5 cos theta times by sine theta minus 16/25, 1 over cosine squared theta. Now we know 1 over cosine squared theta is sec theta, so we can write sec theta, sec squared theta. All right, so therefore now that gives us 3 is equal to 16/5 tangent theta minus 16/25. Sec theta can be changed into 1 plus tangent squared theta. Okay, all right, let's just move into the next page. We are definitely on the right track, okay? So therefore now, all we have to do is expand and simplify. I guess I want to just simply times everything by 25. Let's just see what's the, yep, times everything by 25. So we get 75. Is that 25 times by 3? Yeah, 75 is equal to 32. Nope, that's not 32. That's equal to 80. Tangent theta minus 16, 1 plus tangent squared theta. All right, let's move it. Everything to the left-hand side. So we end up with 16 tangent squared theta minus 80 tangent theta. And then we have 16 plus 75, which is 91 equals to 0. Let's hope that's the answer. 16, 80, 91. Yep, that is the answer to the question. Now, the last question here, find the 2 possible value of theta for which, to the nearest minute. Okay, now, why we have 2 possible theta here? I like to just simply draw a diagram for you to see what's going on, really. If you think about this, right, let's just say if there's a wall here, and you're throwing something, and you want to just clear the wall. For the particle, just clear the wall. There are 2 different ways you can throw the there are 2 different angles where you can throw the particle just to clear the wall. The first one is just like this. Okay. The second one is you have a large angle, and the particle is going up, and then down, and then just clear the wall like that. So therefore, that we do have 2 possible angles, like theta 1, and we can have a different theta 2, where the particle still clear the wall at the same place. Okay. All right. So therefore, in this case, all we have to do is solve this equation here. So question D is just solve the above equation. Okay. All right. How do I solve this equation here? I want to use the cross method to see if that works. Okay. 4, 4. No. Okay, you know what? I'm just going to use the quadratic formula this time. It's minus b, okay, so which is 80 plus minus 80 squared minus 4 times by 16 times by 91 over 32. Yeah, maybe that's just easier, so I don't have to figure out which one is the best, to separate. So we've got 80 plus minus square root of 576 over 32. 576, when you square root it, that becomes 24. Nice. All right, so we've got this. All right, so we've got tangent theta equals to 80 plus 24 over 32. That's 3.25 for the first one. And second one is when we have a minus, and that becomes 1.75. All right, so we should be able to find out what's the angle based on this. It's to the nearest minutes, I think. For So the first angle here is 72 degrees and 54 minutes. And for the second one is okay, 60 degrees and 15 seconds. Okay, so these are the two angles where you can throw this particle and then you know, at these two angles, and then the particle is still going, or the object or the particle, it doesn't matter which one, is going to clear the wall, or it's going to just pass through this point, or you can just hit that point. Okay, now if you look at these two angles here, they're very similar actually. Okay, it's not like, you know, there's a big angle and a small angle from my diagram, simply just because of the diagram. As you can see here, it's more sort of symmetrical. Okay, as you can see, that's 16, that's also 16. So therefore, you know, both horizontally and vertically, there's not much difference, and that's the reason why the angles are very similar to each other as well. All right. So yeah, that's all. You know, 2 questions I think it's enough. All right. For the extension 2, they can give you pretty hard question eventually, but last year's in the paper they give you a very simple projectile motion question. So I guess my suggestion is just try the exercise, and I'll probably give you more, you know, harder projectile motion question later on to do. But first, try the exercise. All right. Thank you. Thanks for watching.